A circus artist is climbing a 20-meter long rope which is tightly stretched and tied from the top of a vertical pole to the ground. Find the height of the pole if the angle made by the rope with the ground is 30 degrees. So here this angle is 30 degrees and the length of the rope is 20 meters. We need to find the height of the tower. So here I need to find AB. I'll consider it as H. So see here we have theta, opposite and hypotenuse. Theta, opposite, hypotenuse. So I'll use the ratio sine theta. Sine theta is opposite by hypotenuse. So here sine theta is 30 degrees, opposite is AB, hypotenuse is AC. Sine 30 value with the help of trigonometric ratios table. So sine 30 is 1 by 2. Sine 30 is 1 by 2. So if you use this value, sine 30 1 by 2 equals AB is H and AC is 20. If you cross multiply, 20 by 2 equals H. 2 times 1, 2 times 10. Therefore, the height of the pole is 10 meters. Height of the pole is 10 meters. A tree breaks due to storm and the broken part bends so that the top of the tree touches the ground, making an angle 30 degrees with it. Now see here, I'll take the total tree as A, B. Suppose the tree has been broken at point C. This part, the broken part, fell on the ground by making an angle 30 degrees with the ground. So here total tree was like AB, but here it broken and the broken part BC, it fell here, like touches the ground at a point P. Now the distance between the foot of the tree and the point where top touches the tree, foot of the tree and where this top touches the ground is 8 meters. So this distance is 8 meters. Now we need to find the height of the tree. See here they didn't mention find the height of the tree before it was broken. So if they'll tell before it was broken, so we need to find X and Y. We need to find the values of X and Y. So first I'll find X. See this Y part is over here. This broken part is here. So first I'll take in triangle APC. Triangle APC. Theta, opposite and adjacent. Theta, opposite and adjacent. That is tan theta. Tan theta is opposite by adjacent. So tan theta is 30 degrees. Opposite is AC. Adjacent is AP. Tan 30 is 1 by root 3. AC is X and AP is 8. If we cross multiply, 8 by root 3 equals X. This is the part AC. Next in the same triangle APC, theta, adjacent, I'll use 8 and Y, adjacent hypotenuse. Theta, adjacent hypotenuse, I'll use the ratio cos. Cos theta is adjacent by hypotenuse. Now cos theta, cos 30 degrees, adjacent is AP, hypotenuse is CP. Cos 30, see you will get the values in the trigonometric table. So if you remember directly you can write here, just before I use tan 30 is 1 by root 3 and cos 30 is root 3 by 2. AP is 8 by CP is Y. So if we'll cross multiply, root 3 Y is 16. So Y value is 16 by root 3. We need to find height of the tree before it was broken. So that is X plus Y. X is 8 by root 3 and Y is 16 by root 3. So LCM if we'll take root 3, 8 plus 16, which is 24 by root 3. Rationalize the denominator into root 3 by root 3. So 24 root 3 by 3, which is nothing but 8 root 3 meters. So height of the tree before it was broken is 8 root 3 meters. A contractor plans to install 2 slides for the children to play in a park. For the children below the age 5 years, she prefers to have a slide whose top is at a height of 1.5 meters, height 1.5 meters, and is inclined at an angle of 30 degrees with the ground. An angle is here 30 degrees. Whereas for elder children, she wants to have a steep slide at a height of 3 meters, height is 3 meters, and inclined at an angle of 60 degrees. Another one, P, Q, R. Here inclined an angle of 60 degrees with the ground. What should be the length of the slide in each case? So here we need to find X. In this case we need to find Y. So here theta opposite hypotenuse. Theta opposite hypotenuse. Here I'll use sine theta. Sine theta is opposite by hypotenuse. So sine angle is 30 degrees, opposite is 1.5, hypotenuse is X. Sine 30 value in the table, like say here, sine 30 in the table you'll get like 1 by 2. If you'll memorize the values, it's fine. Otherwise, you can write the table and you can substitute the values. X equals 1.5 into 2, which is 3 meters. In the same way, in this theta opposite hypotenuse, so sine theta is opposite by hypotenuse. So sine 60, opposite is PQ, hypotenuse is QR. So sine 60 value in the table, sine 60 root 3 by 2, and PQ, which is 3 meters, by Y. If you cross multiply, root 3 Y equals 6, Y equals 6 by root 3. On rationalizing root 3 by root 3, you'll get 6 root 3 by 3. 3 times 1, 3 times 2. Therefore, the length of the slide is 2 root 3 meters. 2 root 3 meters, and this is 3 meters. The length of this slide is 3 meters. The length of this slide is 2 root 3 meters. The angle of elevation of the top of a tower from a point on the ground, which is 30 meters away from the foot of the tower, is 30 degrees. Find the height of the tower. So here the angle of elevation of the top of a tower. So if we take the tower AB from a point on the ground, from a point P, angle of elevation is nothing but the angle between horizontal surface and line of sight when the object is above the point of observation. Means if you are seeing something up, then the angle between line of sight and horizontal surface is angle of elevation. Angle of elevation is here 30 degrees. We need to find the height of the tower. 30 meters, the distance between this point of observation and the foot of the tower is 30 meters. Now here, theta opposite adjacent. Theta we have opposite, I need to find adjacent. So the ratio of opposite and adjacent is tan. So in triangle PAB, tan theta is opposite by adjacent. So tan 30 degrees, opposite is AB, adjacent is AP. Tan 30 degrees, you will get the value in the table, that is 1 by root 3. 1 by root 3. Tan 30 is 1 by root 3. Now see, tan 30, 1 by root 3 equals AB. AB is H and AP is 30. So if you will cross multiply, 30 by root 3 equals H. So on rationalizing, H equals 30 by root 3. I'll rationalize the denominator, root 3 by root 3, which is nothing but 30 root 3 by root 3 into root 3 is 3. 3 times 1, 3 times 10. Therefore, the height of the tower is 10 root 3 meters. A kite is flying at a height of 60 meters above the ground. So, a kite is flying at a height of 60 meters above the ground. So, this is 60 meters. The string attached to the kite is temporarily tied to a point on the ground. The inclination of the string with the ground is 60 degrees. So at this point the inclination is 60 degrees. Find the length of the string assuming that there is no slack, means the wire is like straight, there is no slack, means it is not bent something. So we need to find the length of the string. I'll consider it as x. In this problem, in triangle PAB, see we have angle, this is opposite to the angle and this is hypotenuse. Theta opposite hypotenuse, so sine theta, I'll use sine ratio, opposite by hypotenuse. Sine 60, opposite is 60 meters, sine 60 degrees, opposite is 60, hypotenuse is x. So if you cross, first substitute root 3 by 2. Sine 60 value, see in the table, you'll get root 3 by 2. Sine 60, root 3 by 2 equals 60 by x. If you cross multiply, root 3x equals 120. X equals 120 by root 3. If I rationalize the denominator into root 3 by root 3, x equals 120 root 3 by 3. 3 times 1, 3 times 40. So which is nothing but 40 root 3 meters. So length of the string is length of the string is 40 root 3 meters. A 1.5 meters tall boy is standing at some distance from a 30-meter tall building. So here I'll take AB, I'll consider it as a height of a boy which is 1.5 meters and 30-meter tall building. I'll draw here P Q. This is building and AB is a height of the boy. So if I'll draw the horizontal surface here, the angle of elevation from his eyes, whenever in the problem they'll mention eye, we need to consider the height of the person also into the problem. Now the angle of elevation of his eye increases from 30 to 60 as he walked towards the building. So first the angle of elevation was 30. As he walked towards the temple, towards the building, sorry, so here I'll take it as like C. At this point the angle of elevation increases from 30, it was, now it is 60. So find the distance he walked towards the building. So I need to find BC distance, which I'll consider it as x. Okay, so this is D. See, this total height of the building is 30, but DP or PD is 1.5 meters. Total is 30. So QD will be 28.5 meters. So this CD value I don't have, so I'll consider it as Y. I need to find X. As he walked towards the building, the angle changes from 30 to 60. So how much distance he walked towards the building we need to find. So I need to find X. Now here it's very clear. So first I'll take triangle QCD. QCD. One more time, QBD. Triangle QBD. In QCD, theta is 60. So I'll use tan theta, opposite and adjacent values. Tan theta is opposite by adjacent. So here opposite is QD, adjacent is CD. So tan 60 degrees is 28.5 by Y. Tan 60 is root 3 is 28.5 by Y. If we'll cross multiply, Y equals 28.5 by root 3. If we'll rationalize the denominator, root 3 by root 3. Y equals 28.5 root 3 by 3. So if you'll cancel 3 times 1, 3 times 9, 27, 3 times 5. So 9.5 root 3 meters. Now I need to find x. I got the value of y. I need to find x. Now to find x, QBD in this triangle, theta is 30, opposite is 28.5. I'll use adjacent, which is x plus y in the big triangle. So I'll use tan theta, opposite by adjacent. In QBD, opposite is QD, adjacent is BD. So tan 30 degrees is 28.5 by x plus y. Tan 30 value is 1 by root 3, is 28.5 by x plus y. If we'll cross multiply, x plus y is 28.5 root 3. I need to find x, but I have the value of y. This y value I'll substitute here. X plus 9.5 root 3 is 28.5 root 3. So x equals, on transposing, 28.5 root 3 minus 9.5 root 3. So x equals 19 root 3. 19 root 3 meters. So the distance the boy walked was like 19 root 3 meters. From a point on the ground, the angle of elevations of the bottom and top of a transmission tower fixed at the top of a 20-meter high building are 45 and 60. From a point on the ground, so here I'll take point on the ground. The angle of elevation of the bottom and top of a transmission tower which is fixed at the top of a 20-meter high building. So here AB, I'll take 20 meters. And at the top of this building there is a transmission tower. So BC, I'll take it as transmission tower. The angle of elevation of the C, in the question it is very clearly given, first bottom. The angle of elevation of the bottom is 45 degrees. And the angle of elevation of the top of the tower, this total is 60 degrees. So here we will take P. We need to find the height of the tower. So I need to find BC, which I will consider it as like h meters. Now total AC will be like 20 plus h. Fine. Now here it's very clear. I'll take triangle PAB. Triangle PAB and triangle PAC. PAB and PAC. Now in PAB theta opposite, I'll consider this AP as like x. Theta 45, opposite is 20, adjacent is x. So I'll use tan theta, opposite by adjacent. Opposite is AB, adjacent is AP. So angle is 45. Tan 45 degrees equals AB is 20. AP I consider it as like x. Tan 45 is 1 equals 20 by x. So x equals 20 meters. Now in triangle PAC, tan theta is again opposite by adjacent, but in this triangle PAC, if I take theta as 60 degrees, opposite will become AC, adjacent is AP. So tan 60 equals AC is 20 plus h by AP is x. Tan 60 is root 3 equals 20 plus h by x. If we'll cross multiply, root 3x equals 20 plus h. But the value of x is 20. This I'll substitute in this. So 20 root 3 is 20 plus h. 20 root 3 minus 20 equals h. So if we'll take 20 common, 20 into root 3 minus 1 equals h. Therefore, the height of the tower is 20 into root 3 minus 1 meters. A statue 1.6 meters tall stands on the top of a pedestal. From a point on the ground, the angle of elevation of the top of the statue, and from the same point, the angle of elevation of the top of the pedestal is 45. Find the height of the pedestal. Now see here, I'll take this AB as a pedestal, and at the top of the pedestal there is a statue like BC whose height is 1.6 meters, and we need to find the height of the pedestal. I'll consider it as like h meters. From a point on the ground, the angle of elevation of the top of the statue, this is statue, so here the angle of elevation of the top of the statue is 60 degrees, and from the same point the angle of elevation of the top of the pedestal is 45. This angle is 45. So we'll consider AP as x. We need to find the height of the pedestal, which is AB. AB is pedestal. At the top of the pedestal there is a statue whose height is 1.6 meters. So I'll take triangle PAB. Theta is here 45. Opposite is h, adjacent is x. So I'll use tan theta, which is opposite by adjacent. Opposite is AB, adjacent is AP. So tan 45 equals AB is h, adjacent is x. Tan 45 is 1, 1 equals h by x, h equals x. Now in triangle PAC, angle is 60, opposite will become AC, which is h plus 1.6. Now if I'll substitute like tan theta, if it use like opposite by adjacent. Now in this triangle opposite will be AC, adjacent is AP. Tan 60, AC is h plus 1.6 by x. So tan 60 is root 3 equals h plus 1.6 by x. Root 3x equals h plus 1.6. Now here we have x, h. So I need to find the height of the pedestal. So this x, in place of x I'll substitute h, because h equals x. So root 3h equals h plus 1.6. Root 3h minus h equals 1.6. So here like h if I'll take common, root 3 minus 1 equals 1.6. So if we'll write the next step here, h equals 1.6 by root 3 minus 1. If I'll rationalize this, root 3 plus 1 by root 3 plus 1, h equals 1.6 into root 3 plus 1 by a minus b into a plus b is a square minus b square. So here root 3, here 1. 1.6 into root 3 plus 1 by 3 minus 1, which is 2. 3 minus 1, which is 2. So h equals 1.6 into root 3 plus 1 by 2. 2 times 1, 2 times 0.8. So the height of the pedestal is 0.8 into root 3 plus 1 meters. Units compulsory. So height of the pedestal is 0.8 into root 3 plus 1 meters. The angle of elevation of the top of a building from the foot of the tower is 30 degrees, and the angle of elevation of the top of the tower from the foot of the building is 60 degrees. So here I'll consider AB as a building and PQ as a tower. So this is horizontal surface. The angle of elevation of the top of the building from the foot of the tower. So this is tower. AB is building. The angle of elevation of the top of the building from the foot of the tower is 30 degrees. And the angle of elevation of the top of the tower from the foot of the building is 60 degrees. If the tower is 50 meters high, this is 50 meters high, find the height of the building. I'll consider it as H. AP, I'll consider it as X. Okay, first take triangle APQ. Triangle APQ. And then take triangle PAB. Both the triangles should take PAB. So here it will be 90, like in here it will be 90. So APQ, theta is here 60 degrees, opposite is 50, adjacent is X, so tan theta, opposite by adjacent, opposite is PQ, adjacent is AP. Tan 60 degrees equals PQ is 50 by X. Tan 60 is root 3 equals 50 by X. If we'll cross multiply, X equals 50 by root 3. In PAB, tan 30 is opposite by adjacent. So tan 30 opposite is H by X. Tan 30 is 1 by root 3 equals H by X. So 1 by root 3 into X equals H. As we need to find the height of the building, 1 by root 3 into X is 50 by root 3. This X value I am substituting in place of X. So root 3 into root 3 is 3. So 50 by 3 is height of the building. Height of the building is 50 by 3 meters. If you want, you can write in mixed fraction. 16 into 3. 3 times 16. 16, 2 by 3 meters. Two poles of equal heights are standing opposite to each other on either side of the road. So here, two poles on either side of the road. So AB and CD, which is 80 meters wide. So this total road is 80 meters wide. From a point between them on the road, the angle of elevations of the top of the poles are, here if we'll take a point, this is at an angle of elevation 60 degrees and this is at an angle of elevation 30 degrees. Find the height of the poles equal, so H. I'll consider AP as X, then PC will become like 80 minus X because total is 80. This if I'll consider X, this will become 80 minus X. Now here I'll take two triangles. One is PAB, triangle PAB. Another one, triangle PCD. Now in PAB, theta opposite adjacent. So tan theta opposite by adjacent. Here opposite is AB, adjacent is AP. So tan 60 degrees equals H by X. Tan 60 is root 3 equals H by X. Root 3x equals H. So this you can make it as equation 1. Now in triangle PCD, theta opposite adjacent, same, tan theta opposite by adjacent. Opposite is DC, adjacent is PC. Tan 30 degrees equals H by 80 minus X. Tan 30 is 1 by root 3 equals H by 80 minus X. So 80 minus x by root 3 equals h. This is equation 2. Now from 1 and 2, from equation 1 and equation 2, I can both are equal to h. So I'll equate root 3x equals 80 minus x by root 3. Root 3 into root 3 is 3x equals 80 minus x. So 3x and transposing plus x equals 80. 4x equals 80. X equals 80 by 4. X equals 20 meters. So if you want to find height, h equals here, x value got 20, so height is 20 root 3 meters. So height of the poles is 20 root 3 meters, and this point from where they are observing the angle of elevations of the top of the poles is from the first pole at a distance of 20 meters, and from the second pole PC, which is 80 minus x, 80 minus 20 at a distance of 60 meters. Point of observation from the first pole 20 meters, from the second pole 60 meters, and height of the poles is 20 root 3 meters. A TV tower stands vertically on a bank of a canal. From a point on the other bank directly opposite to the tower, the angle of elevation of the top of the tower is 60. This angle is 60. 20 meters away, the angle of elevation is 30 degrees. Find the height of the tower. Means we need to find here h, and the width of the canal, this CB, I'll consider it as x. So total dB will become like 20 plus x. So first I'll take the triangle ABC. Triangle ABC. Tan theta is opposite by adjacent. AB by CB. Tan 60, opposite is h, adjacent is x, CB is x. Tan 60 is root 3 is h by x. Root 3x equals h. This you can mark it as equation 1. In triangle DBA or ABD, tan theta is opposite by adjacent. Opposite is AB. Now adjacent will become DB. Tan 30 degrees. Opposite is h by 20 plus x. 1 by root 3 h by 20 plus x. If we'll cross multiply, 20 plus x by root 3 equals h. This you can mark it as equation 2. Now from 1 and 2, see from 1 and 2 if I'll equate, like from equation 1 and equation 2 both are equal to h, so I'll equate root 3x equals 20 plus x by root 3. Root 3 into root 3 is 3x equals 20 plus x. So on transposing 3x minus x equals 20, 2x equals 20, x equals 20 by 2, x equals 10 meters. So you got the width of the canal is 10 meters, and that x value will substitute here, h equals 10 root 3. X value is 10, so 10 root 3 meters. So height of the tower, is h, 10 root 3 meters. Next, width of the canal is x, we consider that is 10 meters. From the top of a 7-meter high building, the angle of elevation of the top of a cable tower is 60 degrees. See, from the top of a 7-meter high building, so here AB is a building which is 7 meters. So this I am considering it as like building. The angle of elevation of the top of a cable tower. So tower is taller. Here P, Q. This is tower. So the angle of elevation from the top of a building. So here you need to draw the horizontal surface. Because from here point of observation is at B. So this is 60 degrees. The angle of elevation is the angle between horizontal surface and the line of sight when the object is above the point of observation. And the angle of depression of its foot. Of its foot means the foot of the tower. The angle of depression is this one. The angle between horizontal surface and line of sight when the object is below the point of observation. So this is 45 degrees. So here you can write C. Now CBP angle CBP equals BPA equals 45 degrees because alternate angles. These two are horizontal surfaces, alternate angles. Now if AB is 7, PC also will be 7. PQ is a tower. Now we need to find the height of the tower. So PQ I need to find, I'll consider it as H. Now total is H and PC is 7. So QC will be H minus 7. Now I need to find the value of H. Now see, you can take either BAP triangle. I'll consider the horizontal surface AP as X. So BC also will be X meter. Now I'll take triangle BCQ. Triangle BCQ. In triangle BCQ, theta opposite adjacent. So tan theta is opposite by adjacent. Opposite is QC, adjacent is BC. Tan 60 degrees is QC is H minus 7 by BC is X. Tan 60 is root 3 equals H minus 7 by X. Now take another triangle. You can take BCP or you can take BAP. So I'll take BAP. Theta opposite adjacent. So again tan theta opposite by adjacent. AB by AP. So tan 45 degrees, opposite is 7, adjacent is X. 1 equals 7 by X, X equals 7. X equals 7 meters. Now this X value I'll substitute here in this. Root 3 equals H minus 7 by X value is 7. Now cross multiply. 7 root 3 equals H minus 7. So on transposing, 7 root 3 plus 7 equals H. H equals 7 if you take common, root 3 plus 1. So 7 if you take common, 7 into root 3 plus 1 meters. So the height of the tower is 7 into root 3 plus 1 meters. As observed from the top of a 75-meter high lighthouse. So here 75-meter high lighthouse. From the sea level, the angle of depression of two ships are 30 and 45. So they observe two ships P and Q. If one 30 and 45, so depressions when they saw P, so I'll draw the horizontal surface. Here angle will be 30 degrees. And when they saw the other ship Q, the depression was like 45. The angle of depression is 45 degrees. Here AB is a lighthouse. So if one ship is exactly behind the other, find the distance between the ships. So I need to find X. This I'll consider it as Y. So now I'll take triangle BAQ. But before that, here see, this I'll consider X. XBP, angle XBP equals BPA, angle BPA. So this angle also will be 30 degrees. Alternate angles. And next, XBQ equals BQA equals 45 degrees. Interior alternate angles. Now I'll take the triangle BAQ. Theta opposite adjacent. So tan theta opposite by adjacent. Opposite is AB, adjacent is AQ. Tan 45 degrees, opposite is 75, adjacent is Y. 1 equals 75 by Y. Y equals 75 meters. Y equals 75 meters. So now I'll take another triangle BAP. Theta opposite, this total will become adjacent. Total will become X plus Y. Now tan theta is opposite by adjacent. Now opposite is AB but adjacent is AP. So tan 30 degrees, opposite is 75 by AP is X plus Y. Tan 30 is 1 by root 3 is 75 by X plus Y. If we cross multiply, X plus Y is 75 root 3. But I need to find the value of X. So Y value 75 I'll substitute here. X plus 75 equals 75 root 3. X equals 75 root 3 and transposing plus 75 will look at minus 75. 75 if we'll take common, root 3 minus 1, 75 into root 3 minus 1 meters. This is the distance between two ships P and Q. A 1.2 meter tall girl spots a balloon moving with the wind in a horizontal line at a height of 88.2 meters. See, 1.2 if we'll take out, this is 1.2 meters. So because they told from the angle of elevation of the balloon from the eyes, the angle of elevation of the balloon from the eyes of the girl at an instant is 60 degrees. So height is 1.2. If we'll take out from 88.2 1.2, we'll get 87. So this position will A, B, C, D, E. So now ED will be 87 because 1.2 I am subtracting from it. So after some time the angle of elevation reduces to 30 degrees. So this angle is 30. Find the distance traveled by the balloon. So we need to find BD. I'll consider it as X. And AB, I'll take it as Y. Now in triangle ABC, tan theta is opposite by adjacent. Opposite is BC, adjacent is AB. Tan 60 degrees, opposite is 87, adjacent is Y. Tan 60 is root 3 is 87 by Y. So root 3 Y is 87. Y equals 87 by root 3. Y equals 87 by root 3. And if we'll rationalize root 3 by root 3, we'll get like y equals 87 root 3 by 3, which is nothing but 29 root 3. Y is 29 root 3. Now in triangle ADE, again I'll use like tan theta, which is opposite by adjacent. Here for ADE, opposite is DE, adjacent will be AD. So tan 30 equals DE will be 87, because total is 88.2. If we'll take out 1.2, 87. AD is y plus x. Tan 30 is 1 by root 3, 87 by y plus x. If we'll cross multiply, y plus x is 87 root 3. But the value of y is 29 root 3. The value of y is 29 root 3. I am substituting here because I need to find x. 87 root 3. So x equals 87 root 3 minus 29 root 3. 87 minus 28 is 58 root 3 meters. So the distance traveled by the balloon during this interval is 58 root 3 meters. A straight highway leads to the foot of the tower. A man standing at the top of the tower observes a car at an angle of depression 30 degrees. So here, a straight highway leads to the foot of the tower. So here AB is a tower. A man standing at the top of the tower observes a car at an angle of depression. See, angle of depression is nothing but the angle between horizontal surface and the line of sight. So here he saw the car. Here the angle of depression is 30 degrees, which is approaching, means car is approaching towards the foot of the tower with a uniform speed. So 6 seconds later, the angle of elevation, imagine that the car is at position D after 6 seconds. Okay, so 6 seconds later, the angle of depression of the car was found to be, this angle is 60 degrees. Now find the time taken by the car. From here to here it took 6 seconds. How much time it took from D to A taken by the car to reach the foot of the tower. Now here, see, this I will consider as x. Cbse, angle XB and C equals 30 degrees, which is equal to BCA 30 degrees. So this angle is also 30 degrees. And next XBD, angle XBD equals BDA, which will be like 60 degrees. Interior alternate angles. Now here speed, I will consider it as like x. Let the speed be x. So because CD I cannot write just 6, I need to write distance. So distance equals speed into time. Distance equals speed into time. So here time is 6 seconds, speed is x. So here I'll write as 6x. Here I don't know time, I don't know speed, so I'll write as tx. So CD is 6x because it took 6 seconds to reach from C to D. Now I'll take triangle, find the time taken by the car to reach the foot of the tower. I don't have the value of AB, I'll take H. So triangle DAB, tan theta, tan 60, opposite is H, adjacent is Tx. Root 3 equals H by Tx. Root 3 Tx equals H. This you mark it as equation 1. Equation 2. In triangle CAB, tan 30, opposite is H, adjacent is 6x plus Tx. 6x plus Tx. Tan 30 is 1 by root 3 equals H by 6x plus Tx. So 6x plus tx by root 3 equals h. This is equation 2. Now if I'll equate equation 1 and 2, root 3 tx equals 6x plus tx by root 3. Root 3 into root 3 is 3tx equals 6x plus tx. So if I'll transpose these values, 3tx minus tx equals 6x. So 2tx equals 6x. X and x cancel. So 2t equals 6. T equals 6 by 2. T equals 3 seconds. The time taken by the car to reach from D to A is 3 seconds. The angle of elevation of the top of a tower from 2 points at a distance of 4 meters and 9 meters from the base of a tower. So the angle of elevation from the 2 points. One point is at a distance of 4 meters. The other point, one point is P, the other point is Q. The other point is at a distance of 9 meters. And these are the angle of elevation. This angle and this angle. The angle of elevation of the top of a tower from 2 points at a distance of 4 meters and 9 meters from the base of the tower and in the same straight line with it are complementary. So if I'll consider this as theta, this will be 90 minus theta. This AB is a tower. We need to find true that height of the tower is 6 meters. Now here I'll take the triangle PAB and one more is QAB. PAB and QAB. So in PAB, tan theta is opposite by adjacent. Opposite is AB, adjacent is AP. So tan theta, opposite is H, adjacent is 4. This is equation 1. Now in QAB, tan theta ratio is opposite by adjacent. Opposite is AB, adjacent is AQ. Tan, now angle is 90 minus theta because these two angles are complementary, they told. So one is theta, the other one is 90 minus theta, because complementary angles is nothing but sum of two angles should be 90. So here tan 90 minus theta is H by 9. Tan 90 minus theta is cot theta. Cot theta is H by 9. Cot and tan are reciprocal. So tan theta value will be here 9 by H. Equation 2. From 1 and 2. See, tan theta is H by 4. Tan theta is 9 by H. So I can write as H by 4 equals 9 by H. So H square equals 4 into 9, 36. H equals root 36. Root 36 is 6 meters. Therefore, the height of the tower is 6 meters.